Sir, for when max test?
Maths
Test.
test. Other subjects also conducting.
Yes, sir. English and chemistry completed. Social tomorrow.
For how many marks? For how many marks?
10 marks.
Okay, I will also conduct. Don't worry, and I will inform you syllabus also. Okay. Okay, my dear children. Have you completed your classwork notes? Have you submitted your classwork notes in the
Yes,
Google
sir.
Yes,
Classroom?
sir. Submitted.
Yes. All of you submit your classwork notes regularly and seriously. Okay. So yesterday we have discussed 4 questions so far in this exercise. Yes or no, my children?
Yes, sir. Yes, sir.
Now see the question number 5. Question number 5. What is the question number 5?
So can I read it?
Once read this question.
What can maximum numbers of digits be in the repeating block of digits in decimal expansion of 1 bar 1 by 70? Perform the division to check your answer.
Yes. So let us perform the long division. +1. Who mentioned that one wrongly? Bibina.
Sir, me only, sir.
Who mentioned wrongly in +1?
Sir, instead of 9 standard, I wrote 11 standard, sir.
You wrote, or myself? Who wrote?
Sir, me only, sir. Sir, me.
Okay. It's okay. It's okay. No problem. So yesterday, yes. Good morning, my dear. Bibina, Janej, Nikita, Mahima, Shanti, Srujana, Anmol, Deep, Sri Darshan,
Good
Prince,
morning, sir.
Good
Tushar.
morning, sir.
Yes, good morning, all of you, my dear children. Yes.
Morning,
Now,
sir.
now we are going to discuss question number 5. Here 1 by 17 is given. 1 by 17. We have to find out. The number of digits, the number of block of digits repeating. When you are writing this rational number in the form of a decimal expansion. For that, I told you we use long division. By using long division only, we can identify the number of digits in the repeating block of digits. We can find the number of digits in the repeating block of digits. So I wrote 17 table also. Yesterday, Bibina told. I think who told this table yesterday? Who told
Sir,
this
I
table?
only, sir.
Huh? Bibina only? Yes, I remember that one. So first, when you are performing long division, first of all you have to write the table in rough work aside. After that we start long division. See here, long division. We are dividing 1 by 17. Can you divide 1 by 17? Tell me, my dear Tushar, can you divide 1 by 17? My dear Tushar, can you tell me? Can you divide 1 by number 17? By this table 17? Tushar? Tushar? Not responding? If anybody is not responding to my question, Whether it is right
Yes,
answer
sir.
or wrong answer. Whether it is right or wrong, you should respond to my question. Otherwise, I will remove them from the meeting. What is the use of attending the class if you are not interacting with the teacher? Simply like an audience in a cinema hall without responding to others. What is the use of attending the class? Whether you are telling right answer or wrong answer, it doesn't matter. You should interact with the teacher. When I'm calling any student, when I'm asking any student any question, you should respond to my question. I will ask any student at any time. Okay, my children? Now tell me, Tushar, can you divide 1 by 17? Can you divide 1 by 17?
Yes, sir.
Tell me how can you divide? How many times
Sir,
17 table? How many times goes?
sir, we can divide one by one.
That only I'm asking. Can you divide 1 by 17? We can't divide because here 1 is a smaller number. 1 is a smaller number, 17 is bigger number. So in this case, what will you do here? In this case, what will you do? Tell me, my dear Tushar. What will you do?
Good afternoon, sir.
Yes. Good afternoon, my dear
So
Priyanka.
is this fifth question?
Yes. Question number 5 I wrote. Can you see the
Okay,
screen?
so it was not.
Can
Now
you
it's
see?
visible, sir.
Huh?
It's visible, sir, now.
Okay. See, 1 is a smaller number and 17 is a bigger number. We can't divide this number, smaller number, by a bigger number. That is why we should keep 0 and decimal point, and we keep 1 0 here. Even though here after keeping 0, it is a smaller number, 17 is a bigger number. So we should need to write one more 0. To write one more 0, again we have to keep 0 here and one more 0 here. Okay, my children, if you want to add one more 0, we have to keep 0 in the quotient part. This is quotient part. In the quotient part, we have to write 0 and we have to add one more 0. Now, read the 17 table. See here how many times it goes. 17 table. How many times 17 times table goes here? In 100. 17? 17 5 times. 85. Then what will be the remainder? What will be the remainder? Yes, 15.
Remainder is 15.
So, yes, sir. Okay. Remainder. Remainder is 15. Here also we can't divide 15 by 17. So we can keep here 0 because we have already kept decimal point here. We have already kept decimal point 0. Decimal point here. So we can write here 0. Now 17 table. How many times it goes? How
Sir,
many
8
times?
times.
17?
8, sir.
8 times. 17 8 times. 136. Then what is the remainder? Can you tell me what is the remainder here?
So 14.
What is the remainder here?
Sir, 14.
Yes, 14. So here remainder is 14. Remainder. After getting remainder, in every step, in each and every step, you should write here. Because some reminders again repeat. Then we stop the long division. We stop that long division. When we are getting any remainder second time, we stop that long division. Remember this point. Again, we have to keep 0 because 14 is a smaller number. We can write here 0. Now, can you tell me which
Again, we need to multiply 8.
8, 136. Then what will be the remainder here? What will be the
Sir,
remainder?
4.
Yes, 4. Here 4 is a smaller number, so we can keep 0 here. How many times it goes here? Can you tell me? Here remainder is 4. Remainder is 4. Now 17
2 times.
17 2 times. 17 2 times 34. Then what is the remainder here?
So 6.
6. So here 6 is a remainder. So keep here 0. 17 table. Again, how many times it goes?
So 3.
17 3 times. 51. Then what will the remainder? What will be the remainder?
So 9.
9. So right here, remainder 9. You have to focus on reminders also, my children. When we are getting any reminder repeated, then we stop this long division. Here 15, here 14, here 4, here 6, here 9. Again we keep 0. 17 table. Again how many times it goes?
So
Yes,
5.
5. 85. Then what will be the remainder?
So 5.
5. Remainder 5. Immediately after getting the remainder, immediately write here side remainder is equal to 5. So again we have to keep 0. 17 table, how many times it goes?
So 2.
2 times. 7 to 34. What is the remainder here? What is
So
the remainder?
26.
16.
16. So right here remainder is 16. Zero. 17 table. Again, how many times it goes?
So 9.
9 times. 9 times. 153. In the next page, I am writing the remainder. What is the remainder?
So 7.
7. 7 is the remainder. I am writing that remainder in the next page. That is equal to 7. Remainder is 7. Again we keep here 0. We have to concentrate on remainders also. If any remainder is repeated, if we get the same remainder as we got previously, we stop this long division. Please remember this point. Next, 17 table. How many times it goes here? 17 in 70.
So 10.
17 4 times. Yes or no?
Yes, sir. 4.
It's a 4.
68. 68. Then what will be the remainder here?
So 2.
2. 2 is a remainder. Immediately you should write here remainder. Remainder is equal to 2. Again we have to keep 0. How many times it goes? 17 table here?
So 1.
17 1 times. 17 1 times. 17. Then what will we get?
Remainder 3.
3.
3.
3 as remainder. Again we have to keep here 0. We have to concentrate that remainders. We have to check after getting every remainder whether we have got the previous reminders. Okay.
Sir, it goes with 1, sir.
Only 1 time. 17 1 times. 17 1 time. Then what is the remainder?
So 23.
23. 30 minus 17. Subtractions.
13.
Huh?
So 13, sir.
Yes, 13. Remainder is 13. Have you got previously 13 as remainder? Once check. We did not get 13 as remainder in the previous remainders. Okay. Now again we have to keep 0. Now 17 table. In 130, how many times it goes? How many times it goes?
So
So 7
7.
times.
7 times. 119, 119. 7 times. 119. Then what will you get here? Remainder?
So 11.
11. 11 as remainder. Remainder is equal to 11. Have you got remainder as 11 in the previous remainders? Once check. Have you
No,
got?
sir.
No. If you get the same remainder in the previous remainders, we stop that long division by that step only. We remember this point. Again, we have to keep 0. 110. How many times it goes?
So 6.
17, 6 times. 6 times here. What is 17, 6? 1 or 2? What will be the remainder here?
So 8.
8. 8 is remainder. Remainder is 8. Again, keep here 0. How many times 17 table goes here?
So 4 times.
So 4.
4 times. 4 times. 68.
So 12.
12 is remainder. Again, we have to keep 0. How many times 17 table goes here in 120?
So
So
7
7.
times.
7 times. 7 times. We should keep here 7. And 119. What is the remainder here?
So 1 is reminder.
1 is remainder. Have you got 1 as remainder in the previous steps? See here.
No, sir.
No, sir.
Okay. 1 is nothing but this only, the given number.
Sir, we divided with the 1, no sir.
The
So
given
it will
number
be 1
itself.
only.
The given number itself is 1. Yes or no? The given number itself is 1. So we can stop here by this step. We can stop by this step. And we keep here borrow symbol, because again we do the same division. Again we keep here 2 zeros. Yes or no? Again we get the same reminders as continuously, infinitely, many times. So we keep borrow symbol and under this just above all these digits. Okay. Therefore 1 by 17 is equal to 0.05882 35 294 11 76 47. After that again we get the same 005 like this. So we stop this long division by this step and we keep bar symbol. Now count how many digits are there in this repeating block of digits. How many digits are there? Count how many digits are there.
Sir,
So
16.
16.
Yes. Number of digits. What they asked here? Number of digits in repeating block of digits. In repeating block of digits, totally 16 digits are there. So maximum number of digits is here 16. not more than 16. Okay, my dear children, that's all.
Okay, sir.
Okay, now this is about writing a fraction into a decimal form, and previously we had discussed a decimal number, how to write a decimal number, either it is a terminating decimal number or non-terminating recurring decimal number in the form of p by q. In the previous classes we had discussed that point. Yes or no, my dear children?
Yes, sir.
Yes, we had discussed that point also. So every time, first of all, write the classwork notes which I am posting in the Google Classroom in the form of PDF. First of all, write the classwork notes and keep that classwork notes opened nearby you, and after that watch the YouTube link what I am posting a video in the Google Classroom. That is nothing but the class of that particular day. That particular day class is posted in the form of a video. First, what should you do? First, write the classwork notes and keep that classwork notes opened, and open that YouTube link. Watch that video and understand the points or concepts which were explained in the video by keeping your classwork notes open nearby you. Then you can understand these concepts well, and you can understand the solutions also well. Even though if you are having any doubts after watching the videos, by keeping your classwork notes nearby you, then call me personally by phone and get your doubts clarified. Okay, my dear children, will you follow these instructions sincerely and seriously? All of you writing the classwork notes and submitting their classwork notes in the Google Classroom. It is well and good. In addition to that, keep your classwork notes aside nearby you and open the YouTube link which I am posting in the Google Classroom. Are you finding the YouTube links in the Google Classroom, my dear children, every day?
Yes, sir.
Yes.
Yes, sir.
So keep your classwork notes opened nearby you, and then open that YouTube link. Then you can watch this class of that particular day. You can watch the mathematics class of that particular day. Okay, my dear children, will you follow these instructions sincerely and seriously?
Yes, sir.
Yes. Now, let us discuss about non-terminating, non-recurring decimals. These are called irrational numbers. Non-terminating, non-recurring decimal numbers are called irrational numbers. Now let us discuss the definition of irrational numbers. Previously, we have discussed about rational numbers. Can you tell me the definition of a rational number? Anyone? Tushar? Tushar, can you tell me the definition of a rational number? Wait, my dear Shanti. Wait. I will ask you. Don't worry. Okay, Mahima, I will ask you. Tushar, not responding to my question. Okay, my dear Srijana, I will ask you. Tushar, shall I remove you from the meeting? Shall I remove you from the meeting, my dear Tushar? No response from you? My dear Tushar, just you have joined the meeting, but no response. You went somewhere, I think. You went somewhere, just to open the link, YouTube meeting link, and you went somewhere. Yes or no? You are not there online. I'm removing you from the meeting because you are not responding to my question. Previously, I told you clearly, my dear children, if anybody is not responding to my question, even though you know the answer, whether it is right or wrong. Suppose if you don't know answer, simply say, sir, I don't know the answer, sir. At least respond to my question like that. Okay, my dear children?
Yes, sir.
Yes. Here I removed Tushar from the meeting because he is not responding to my question. What is the use of attending the class without interacting with the teacher? What is the use? Simply like an audience in a theater, film theater, cinema theater, just like an audience. If you are not interacting with the teacher, what is the use? You have to ask the questions, you have to get the doubts clarified, you have to answer to the questions. Yes or no? Anyone? Can you tell me any Janej definition of not only that point, my dear Trinson? Yes, Mahima, tell me. All of you listen carefully. Okay, Srijana, I will ask you next question. Srijana, I will give you next chance. Now Mahima tells the answer.
Yes, sir. The number which can be written in the form of P by Q, where P and Q are integers, Q is not equal to 0.
Very good, Mahima. This is the complete, correct definition.
Yes, sir.
Yes. Next one, irrational numbers. Okay, down your hand, my dear Mahima. Thank you, my dear Mahima. Down your hand. Okay. Now we will
Yes,
discuss
sir.
about irrational numbers. Simply, we have discussed previously the numbers which cannot be expressed, in the form of P by Q, where P and Q are integers and Q is not equal to 0. That is one definition. And another definition, with the help of decimal expansions, we are defining irrational numbers as the decimal expansion. If a number is in a decimal expansion, it is neither terminating nor recurring. That kind of decimal expansion is called irrational number. A number whose this is another definition of an irrational number. Okay, my children. A number whose decimal expansion is non-terminating, non-recurring, it is called an irrational number. In other words, the decimal expansion of an irrational number is non-terminating, non-repeating. The decimal expansion of non-terminating, the decimal expansion of an irrational number, the decimal expansion of an irrational number, the decimal expansion of an irrational number is non-terminating.
Sir, can you please move the screen little size?
Okay, non-terminating.
Yes, sir.
Example 2.10 110 110. This is an example for an irrational number. If you observe this decimal expansion, if you observe this decimal number, no digit or no block of digits is repeating, but a pattern is following here. This number is following a pattern, but it is not recurring, non-repeating. Okay, my dear children, this is an irrational number. Similarly, 13.150 15150. Like this, we can take any decimal expansion which is non-terminating, non-recurring. That decimal expansion is called an irrational number. Okay, my dear children, this is another definition of irrational number. Previously, we have learned the definition of an irrational number as a number which cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. That is one definition of an irrational number, and this is another definition of an irrational number. A number whose decimal expansion is non-terminating, non-recurring. If you observe these numbers, these are non-terminating because at the end of the number we kept dots. Dots means there is no ending. Non-terminating, non-terminating. And moreover, no digit or no block of digits is repeating. No digit or no block of digits is repeating. Understood this definition, my dear children? Second definition of an irrational number.
Yes, sir. Understood.
Yes.
Yes, sir.
This is another definition of an irrational number. Now come to the question number 8. Okay, question number 7. See the question number 7. Question number 7. See the question number 7. Okay, my dear Srujana, can you read the question number 7? Question number 7.
Yes, sir. Write three numbers whose decimal expansions are non-terminating, non-recurring.
So indirectly, they asked irrational numbers. Yes or no? Non-terminating, non-recurring decimals means they are nothing but irrational numbers. We have written two examples. We can copy these two examples as it is because these decimal expansions are non-terminating, non-recurring. Okay, my children. But they asked three numbers. Okay. So the following three numbers whose decimal expansion or non-terminating? Non-terminating, non-recurring. Non-recurring. Can you tell me one example whose decimal expansion is non-terminating, non-recurring? Just I have told you two examples. These are two examples.
Sir, we can write the same number also, sir.
Yes, you can write the same numbers also. 2.10. So 2.10, 110, 1110, 11110, and so on. And another example here, see here, 13.150, 15150, 1515150, and so on. Another example, I am taking one more example, 4.32, 332, 332, like this. Just to increase these digits, number of digits, that's all. In between, we keep some number, same number. Okay, my children, 4.32, 332, 332, 432, and so on. These are some examples of irrational numbers whose decimal expansions are non-terminating, non-recurring decimals. Okay, my dear children, understood? Like this.
Understood, sir.
Yes, just to take
Yes,
one
sir.
decimal, take one number. Here I have taken 1. In this case, I have taken 15. I repeated 1 time, 2 times, 3 times. In between, write as your wish any digit. In this case, I wrote 2. I have taken 3. I wrote double 3. Here I wrote triple 3. Here I wrote 4 3s. In between, write any digit as your wish. Any digit. Understood this point, my children? Right. Similarly, just I will ask you one more example. Can any one of you tell
Sir,
me?
can I?
Yes, my dear Bibina, tell me.
Sir, can I write it in the chat box or I will tell?
Tell the answer.
Sir, example 8.21,
21,
221,
221, right?
331,
221. Okay.
then 421, then it goes on, sir.
Yes, 4 2 so on and so on. Like this. Understood, my dear? Janej, Nikita, Mahima,
Yes, sir.
Shanti,
Yes, sir.
Srujana.
Understood.
Sir,
Yes, like this.
Yes, sir.
We can write like this infinitely many irrational numbers. Okay, my dear children, you should follow some pattern of numbers like this. Here 2, double 2. Bibina said this one, triple, that also. Yes, my dear Bibina, 9, 1110. Like this, we can write infinitely many numbers whose decimal expansion is non-terminating, non-recurring. Okay, my dear children. Now come to the question number 8. Yes, okay, my dear Mahima. Okay, my dear Mahima. Now come to the question number 8, my dear children.
Yes.
Okay, my dear children. Now the time is 12 past 33 minutes. 12 past 33 minutes. Now you can leave the meeting, my dear children. Take rest. Take care of your health, my dear children. But follow
Thank you,
the
sir.
given instructions sincerely and seriously. Follow the given instructions sincerely and seriously. and take care of your health, my dear children. Stay at home, stay safe, sanitize. Okay, ma. Okay, my dear Bibina. Okay, my dear Bibina. Stay at home,
Thank you, sir.
stay safe, sanitize your hands frequently, maintain social
Thank you, sir.
distance, my dear children. Thank you all.
Okay, sir.
Thank you all, my dear children.
Okay, sir. Thank you,
Thank
sir.
you,
Bye,
sir.
sir.
Thank you, my dear Janesh. Thank
Thank
you,
you, sir.
my dear Bibina. Thank you, my dear Srujana.
Thank you, sir.
Thank you, my dear Jesslyn. Thank you.
Thank you, sir.
Yes, thank you, my dear Janesh.